welcome to the Bak Up Podcast, a show on how technology is changing the way we live and do business. I'm your host, Ioannis Bakagiannis. Bak Up is ready to start. Hello. This is episode 8 of the Bak Up Podcast. Our guest in this episode is a schoolmate of mine and a great robotics engineer. He, as myself, graduated from Electrical and Computer Engineering School of the National Technical University of Athens, and then he moved to the heart of the engineering industry in Europe, Germany. Since 2013, he has been working as a robotics software engineer and currently works for Franca Emica, but I hear that he has some news to share. He is Konstantinos Vasios. Konstantine, welcome to the show.
Hi, John. It's great to be at your show. Yeah, thanks so much for having me here.
Oh, our pleasure. First of all, let's start right there. You have been in Germany for the past 7 years, and accounting, and right now you have decided to abandon ship, or what is going on?
So yes, as you said, I was working in Germany for 7.5 years, and I thought that could be a good time to reconnect with our roots, Athens. And indeed, I found a great career opportunity. So in Athens, again as a robotics engineer, this time I'm abandoning land and I'm just going underwater. Building algorithms this time for a submarine, an autonomous, semi-autonomous submarine, in a very promising project, European funded project called SlickShip.
Wow.
SlickShip, indeed. It's really promising indeed. I'm really hyped about the project and the prospects there. Yeah.
That's a very.
And I think also being a Greek guy, I think you share this. Being in touch with the water and the water element, it's great, and also being able to apply robotics and this kind of knowledge in this domain sounds really promising as well.
That's great, and the best thing is the name. I'll stand by it. SlickShip. I love it.
SlickShip. As a part of I did not mention that is the Welding Institute, the TWI. The headquarters are in Cambridge, UK, and there's also a TWI Hellas department in Athens.
Yeah, I think many international corporations are looking right now Greece as an option, at least, since we haven't been in the map for so many years, but right now they're looking at Greece as an option for a potential R&D or a place where innovation could be fostered.
Absolutely. Yeah, I see this trend as well unfolding. Although there is also a fair well of criticism on the amount of foreign investment our country was able to absorb. But I think it's you also see the trend being positive. I can confirm that. But I mean, there's so many polytechnic schools. You have all these universities and local talent, and seeing companies like Tesla investing in Athens and making R&D department with some good colleagues of mine. And I think if some one of these guys from Athens are hearing this podcast, I would just dare them to join you in this podcast and for another episode. I think that would be great to share their experience as well. And I'm pretty sure they will have a lot to say and share about how they managed to bring Tesla from California to Athens, and that would be great.
Yeah, that would be amazing. That's a really big feat, a big accomplishment for Greece in general,
Absolutely
not for the engineering department only. And definitely one thing that I definitely agree with you is that the talent is there. Yeah. Greece has lots of really good engineering and applied sciences schools for sure. And that leads me to our university years.
Yes.
That I remember vividly back then that you majored around control and systems theory,
yes,
very around that they are tightly coupled with robotics. What drove your decision to be a robotics software engineer?
Back then, our school, as great as it is, I think there is a major, maybe I'm allowed to say that, a big flaw.
There is a
Like you
big
have
flaw for sure,
there is a big flaw,
and not only
and
one.
maybe not only this is not only tied to our specific curriculum of studies. Like you have all this, you have 60 courses over 5 years, and it's really hard for a student, I think, to grasp the overall image of what's happening outside. Like it's let's say you have all this over specialization over so many fields, and it's really hard to grasp a general picture of what this profession is about. At least that was my case. That was hard for me. So many courses and hard to see a real picture. In the end, eventually, after 5 years of studying, you start seeing stuff, and after working, especially, you start realizing stuff. But back then, at least for me, it was really foggy, the whole spectrum. And so when I came to the it was like sixth semester, studying like control systems. That was a revelation for me. Like I didn't know the existence of such a solid discipline that is really mature now. You have a theoretical mathematical framework that is being developing for 100 years almost, and you realize that in the backbone of every major technology breakthrough, someone would argue from what's steam engine and the centrifugal regulator till the most modern technologies in robotics, there is a backbone, a central piece that is control theory. And that's like I was captivated. Like you have in every major discipline this piece of technology that is so mature and has so much rich mathematical framework to work with. And that was it for me. It did it. And also, it's as you read in modern AI books, like the classical Peter Norvik's book, that control theory is considered to be a subfield of the generic field of AI. And so, yeah, that did it for me. The concept of a central agent that gets information, calculates, and throws out something as an actuation. I find it magical, and still, I think I still find it magical after working 7.5 years in the field. It still continues to be a great motivator for me.
There are so many things that to unpack there. The Bellman equation is so beautiful. Is amazing, and it has applications to everywhere. Even in game theory, you can imagine that it is worked and it's applied there. And many people have argued in the AI field that definitely we need to go back to our control background because we haven't harnessed the power of the mathematical tools that they
Yes.
are available from such a rich
Yeah,
history of research. And definitely, I
absolutely.
agree with the flow of the National Technical University of Athens, and I think it's a common denominator between
Yeah.
universities in Greece, and that's I think that's the since I've been in Canada and Greece, that's the biggest difference. That schools here tend to have more focus on what you're gonna do afterwards. Uh, Less in the engineering spectrum because again you have to understand and you have to go through all the math and physics. That's I don't think we can avoid that anytime soon.
Yeah.
uh,
True.
Maybe walking through some how to be an AI engineer in 6 months YouTube series. Maybe we can we can learn all the necessary stuff
Absolutely.
necessary stuff there. Uh, but what it means to be a software engineer? Like, what's your day like? What do you do in your role?
Just first, let me say something out loud that I have a serious problem with titles.
Okay,
Like,
great. Me too.
I try to come as close as possible to the real thing I'm doing with the title, but I don't think that I'm succeeding. So, in the end, like, if someone is able to be a really solid computer scientist and really good coder, good with software, and at the same time you're domain specific and you apply domain expertise in robotics and control theory, you're practically a unicorn. Not
Yeah.
that many people do that. Like solid software engineering background at the same time control expertise. Like the industry here, let me tell you, like people want to invest so bad in robotics, and they have so much hard time, so hard time to find talent in a single person that combines these two, and he has a broad spectrum. And this is also something I'd like to mention. I would like to mention before is like you have this kind of regarding the over specialization in our school. Robotics is so wide, and it's a very universal field. Like you capture everything from philosophical aspects of being, let's say, till very practical like electronics engineering and hardware pieces to so like every possible major any undergraduate program. It needs to be combined in order to succeed in robotics. You need to be so diversified in your knowledge to be able to succeed. And there is this kind of the classical trap and dilemma between being a generalist or a specialist. And it's really hard, and I think this is one of the most hard things to do in robotics. So being a robotics engineer in a software robotics engineer is basically applying the computer science fundamentals in combination with classical control, signal processing, and robotics field into trying to bring this to as close as possible. I hope I covered the question there.
So yeah, so you code and you apply the control theory at the same time. And you say that's somewhat hard to find as a skill set. Does it need to be one person? Like,
good question.
Could you have like a coder and in a team, for example? Let's say we split those two. We're gonna have somebody that can code 100% of the time, and somebody that can apply the theory. Because trust me, I've seen theoretical people's code, and it's not pretty.
Exactly, true. It's a like this is exactly the main sales point of the MathWorks ecosystem, MATLAB Simulink ecosystem. So that's absolutely what these guys offer. They say to you like, be domain specific in your control theory with Simulink and being able to do everything like with graphical programming, and we generate code for you. Don't overthink about the code implementation, and they're quite good actually. Like if you are disciplined and you follow the guidelines, the code you generate in the end is quite good. I did that a lot during my career, and I have to say there are tools out there that will allow someone like in the same way maybe in comparable fashion to what a photographer does with Photoshop. Like you can concentrate on your field and your domain without really caring so much about the substrates of computer science. But in the end, like if you need really super high performance, if you're in a very competitive field and you need to be top in your game, in the end, you need to be a good coder. There is no substitute for that. It's everything relativistic. Like another thing, trying to answer in your question is, if you're like a project manager, you try to manage a team, it's good to be a generalist and know something about every field, like classical formulation there. But again, if you are an engineer and you want to be top in your game, you need to have both. You need to invest. You need the time. You need to put the time in. I don't personally see any substitute. They're two really hard disciplines, but combining that into a person, like that's really powerful.
Yeah.
What I end up seeing is like companies in this field tend to separate, like have a specific department of control where people concentrate on their domain. They build a specific software module, and a software team of engineers that supplements them, builds AIs, smart AIs around them, and incorporates this piece of code, this implementation into a larger scheme of software design. So it's a hard one. It's a hard one.
And as I mentioned, you decided to go work for the German industry, arguably one of the most well-known robotics industries. Can you give us some insight about your path in Germany, where you started, if you changed
Yeah.
uh, roles, paths, or mindset during these 7 years?
Yeah, that's a great question actually, and so it was not a linear path by any means. So I did my master thesis with the help of the supervision of our professor Konstantinos Vasios. Was a really nice talk. It was about a robotic hand, simulation, robotics manipulation, and developing algorithms. And I have to say back then that the main research about this diploma thesis, like the fundamental work, was the research from the DLR, the Robotics Institute here in southern Germany. This specific type of technology for the so-called collaborative robots. It's a technology that has a big part of its foundation is founded here in Germany, and especially in close to Munich. That was my basis. This was my foundation, let's say. After that's like natural, you would probably think that a PhD was a natural thing to do. But honestly, like back then, I was really curious to see how real stuff are made. I, when I say that to my to friends of mine that are PhD students, and I say real stuff, like they get a bit offended. I'm not trying to diminish PhD's
Whatever,
work about like
whatever, dude.
yeah, it's everything is real, and I like theoretical work. I really admire theoreticians, but that was my internal, my quest, let's say, back then about trying to understand how industry works, and a
To
really
if
good
I could
deal.
if I could interject, because what you're saying has it's the second time that somebody said it in this podcast. Mohammed in the fourth episode, he was describing the why he chose to go to the industry after finishing his
PhD.
PhD, and
Yeah,
what is the difference between a PhD and the in the work that he is doing right now. And he said the stakes are high. That's what he said.
good point. Good point.
We're
Good
doing
point.
if this doesn't work in academia, who cares? You make a paper out of it and say, okay, this doesn't work.
Absolutely. I have to say, like, realizing at some point that your code is going to get deployed into thousands of services and thousands of products, that's some point, if you let that sink in, it's a different game. But at the same time, if you want to experiment and you want to try new stuff and you want to innovate, I might then argue that it's not the best environment to be in, because you need to be rigid, you need to be solid, you need to be disciplined, and trying out new stuff and having guinea pigs and ISO norms around. No, that's I think it's a really reasonable thing to do as you're maybe young and more daring to try stuff in your PhD that also could be the case that they don't work. And afterwards, when the stakes are high, you're mature enough to see the real thing. Again, saying real is not diminishing to the
Yeah.
theoreticians. um,
Sorry, I
so
interrupted you. You were going
no, sure.
about your path.
And I also found back in 2013, although you could see like there was great stuff happening in robotics, it was still a very niche market, and very I found it hard to approach this industry, especially for um, like really interesting projects that are the top notch technology of the time. It was really hard to approach these teams, and if like you could do robotics, but it would be like this classical robotics with just a PD controller, let's say, that do the classical rigid robotics thing. But also a bit, I found it personally a bit non-challenging, a bit trivial. So I want something that I would offer more possibility for innovation and yeah. So back then, a really great opportunity, a really nice deal came up with a company here in Munich. It's called still called Ithaca Engineering, and these guys are really focusing on control engineering. Like they offer to any possible customer technical expertise from anything you can imagine, like from mainly software, but any kind of support with regards to control. Um, Mainly, the customers of this company were BMW and Audi. Mostly, they had to do with the automotive world. So back then, I was really, I found the opportunity being able to design real-world control systems for these giants. It seemed really great, and I did that. It's for 4 years. It was my first career path I joined back then. So a very interesting time to be in automotive, especially in southern Germany back then. because at the same time, like 2012, so you can imagine, I started 2013 working for the German automotive. At 2012, Tesla had their Model S out, and Tesla back then was still an open bet, and no one was really paying attention to what was happening. It was considered Elon's game, and they were, no one was paying really attention. No one was expecting anything. And but on the other hand, like as I kept working, 2013, 14, 15, I was watching this surge of innovation from the US and Tesla, like always trying new stuff, battery technology, software, autonomous driving. And I would expect that I would see the same kind of attitude happening here, like a woke up call, let's say. And the years passed. Don't get me wrong, the guys here and everyone knows that BMWs are doing some they're world class engineers and engineering solutions, but you could feel in the atmosphere that something else is happening here from Tesla guys, and maybe the southern German industry is not catching up that quickly. Again, as an engineer, I was not a top manager, so I could not really evaluate this feeling. But you get that, this kind of feeling. And
For
on the
sure,
other
we're
hand,
gonna
just
talk about Tesla later down the line, for sure.
I was just trying to say about the career path and the
Yeah, yeah.
changes. So that got me thinking, what I'm doing and how do I make sense of it. And I was also missing a bit the robotics part in me from my master thesis, and I was able to find some guys here that were working DLR Institute, and there was a very very young, talented, motivated team, and they had this super rock star professor. It's Sami Haddadi. Now he is the professor that has the leader of the Munich School of Robotics. So Germany is investing heavily in this kind of technology, and I had the opportunity to meet these guys, and I joined them. That was fantastic, and I joined them in a time when they had their first prototype developed, and they wanted to make it mature for the market and roll it out to the customers. And that was really great. Really, really happy for this choice and being able to find robotics again and work for one of the most promising and robotics companies in the world. So this is where I'm starting today. Still, and now going back to Athens from
Yeah,
September.
well, of course, of course, of course, of course.
Uh,
But yeah, let's drill down. You started talking about the automotive industry,
yeah.
and let's drill down a bit more on that topic. You mentioned that you were doing controllers. Can you
Yes.
explain to the people what a controller is, what exactly
Yeah.
does, and where it's being used in which part of the car is being used by?
Yes. I mean, these are stuff that most consumers already observe, but maybe it's hard to put them in this kind of control kind of perspective framework. So let's start by the fact that from the early 90s, as everyone knows, and that was a huge driving factor for everything, it's computational costs were getting lower and lower. So it was really easier year by year, dramatically to make better use of the computational resources and put small computers everywhere pretty much. Someone could start seeing that with the first subsystems, the first control units being utilized in cars were basically the ABS, automatic braking system, and most of them had to do with first safety, and afterwards, adding luxurious items around to make cars more fun. But basically, it was more about how to improve safety with making use of these small computational devices, microcontrollers around the car. And ABS was one of the first uses. Broad commercial applications of this kind of technology, um, like cruise control, for example, is another great example of its automatic cruise control, especially nowadays with the radar. You can have very you can keep a constant distance with the car in front of you, and of course, okay. But these were some of the first applications of this technology. Now, cars, you can imagine, they have even a medium-sized car, the average consumer's car. They incorporate more than 20, easily 25 microcontrollers in a single car. Like you can imagine 25 single small computers, all of them a part of huge networks. making sure that your car is safe, your attitude is safe, trying to assist you, and I'm sure like most consumers are familiar with the safety, the functional safety systems that this car incorporate nowadays. And that was still in 2013. The game here around this, the ecosystem here in southern Germany was developed around that. Like you had so many subcontractors, service consulting firms that were around this ecosystem, trying to provide with the big auto manufacturers like BMW and Audi with all this hardware and software that in order to implement this kind of functionalities around the car. So yeah, quite huge ecosystem. It's really impressive to see that in work. How many people, how many companies compete with each other, so they can provide these services in the big automotive industries. Nowadays, I think there is not even a single part of the car that it doesn't have some kind of microprocessor overwatching the functionality. Something that most consumers probably observed, especially in the decades from 2000 till 2010, was also the dramatic reduction of the consumption of the car. Like especially in European norms or Californian laws were really extremely strict about the consumption of the car. And for us, might be in the 90s, we're really used to the fact that a car could consume 10 liters per 100 kilometers. That was, pretty
Yeah.
standard. Now we're coming into a point where cars like 4 liters, 4.5 liters, that's considered the norm. In order to come to this point, this like the low computational costs and the advanced software and the control systems that are applied into a car are a huge factor into this game, and control systems there have huge part to do. And like my last project in automotive was I think nowadays they're going nuts about that. Like we're able in the latest BMWs, they had a camera system that was detecting the red lights. So it was able to do predictions about the power consumptions, like making predictions about the future, about how statistical possible is that the driver is gonna have he's gonna be needing a huge surge of power. So if you can predict that the possibilities are really low, you can drive down the consumption, like put less of fuel in the engine and drive the consumption lower. Like it started to go crazy after a while. They're getting really advanced into that about driving consumption low.
That's interesting. So, to recap, like a controller is like a processing unit that is overarching of some sub application of the car,
Yes.
and there are many of these processing units within the car, right?
Yes, like easily in an average car nowadays, 2025, like that's if you go into a very advanced top-notch BMW or Mercedes, it will be like 100 easily.
And they are all collaborating through some network probably to drive you from point A to point B. Uh, Other than that, other than these processing units, the controllers that first of all, how scalable is that
Uh,
to like because you're saying from 25 to 100 can in the future be 1,000, 2,000 of these controllers in a car, in a commercial car?
so its controller has a very specific function. It's quite specific to, for example, you have a very specific controller that, and that's also a project I worked in, that is about the electric power steering. You need to control at every point. It has some inputs like the torque that is applied on the steering wheel, the position of the steering wheel, and some other information that gets from the CAN bus, CAN network, and other sensoring information around the car to optimally assist your driving. So this microprocessor is only designed for that, and it's usually part of the system of the EPS, electric power center unit. So it comes from the supplier already equipped with this device. So it's scalable because it's the ecosystem around the automotive manufacturers is really subdivided. Like uh, Bosch will specialize, for example, in some specific components, and these components are produced by the thousands. So, and also the central network architecture of the car is really distributed. They have really standardized the bus architectures and all the networks. So really, it's with this all this layer of communication is so standardized that it's after the manufacturers have done their work, it's pretty much plug and play. Integration testing occurs, of course, in mostly from the manufacturers themselves, the OEMs, and so they've invested in traditional, good old-fashioned software principles to make sure that they are scalable. They've incorporated all the possible software techniques in order to be able to do that in both hardware and software.
Interesting. Because when I'm seeing these type of architectures, usually it's the same with like even agile at work, like project management methodologies, not even coding or systems implementation methodologies. Uh, uh, um, when you fragment its small application, because you can find, like, even with the car, you said power steering, you need to have like this tiny use case. You can have like a million use cases, because oh, we need the controller to smoothly roll down the windows, or rolling up the windows,
Yeah,
or
yeah,
you
yeah,
can go theoretically infinite with so many
absolutely.
functionality. Is that
That's
possible?
actually a great question. That's actually a great question that you, great point there. And the fact that the automotive, the big players did that for the last 20, 30 years, it doesn't mean that it's the optimal solution. And actually, that's a very actual problem because Tesla, again, they centralized everything. They just have a big supercomputer in the car, just one. And they make everything run through this big computer. No fancy networks, no some, maybe they have some small for maybe software, I'm not sure, but the main concept is that they have this huge supercomputer. Now they design also their silicon, so it's really vertical, the whole thing. And the German the big, the traditional OEMs, only not only the German, the French are doing the same as well, and Japanese as well. So they have this multi-distributed, complex network of small devices. So I think your question is absolutely valid, and I don't think there is scalable and like in the true. If you want to make more sophistication and to pull more performance and drive the consumption lower, scaling up this ecosystem of small devices maybe big is good for the economy of Germany, because you have so many players around and so many companies and so many people working around that. But in the end, as a technical solution, it has its flaws, and it really, yeah, I think it troubles really the architects behind BMW and Mercedes and Volkswagen, and it's the Achilles heel of the German automotive industry probably right now. That's excellent point.
And it's the same with the microservices. The main issue at some point, because you in software engineering, you're trying to do all these small services in your website or your application that work well with each other, and the monolithic architecture that is one big thing, and uh, has been mostly abandoned by this time. But on the other hand, people found out that yeah, we can't really turn everything into microservice, because at some point a small application could have like 1,000 microservices, and nobody knows like how these things work with each other. If there is a bug, the dependency trees, there are so many, like there will be dragons in there. If you go down that rabbit hole to fragment everything, there will be
Yeah.
dragons.
Absolutely. Yeah, totally get that point. This analogy holds for this kind of architecture in automotive. as well.
It's the rule that hasn't been broken yet. Let's see. So,
Let's see.
how robotics have propelled the growth of the automotive industry? If we take the controller part away, if is that the only way the robotics have impacted the automotive industry in Germany?
I mean, I guess in your question, maybe when you mention robotics, you mean the control systems in
Everything
general
you can
or
have all
specifically?
this broad because when you say somebody robotics, probably they're gonna think about the hands, like the tools that they make the manufacturer of the car. That's the first thing that people
Okay.
are kind of will
Okay.
remember.
Okay. Exactly. Let's talk about that then. That's the first thing that comes to mind. Usually, people have this image of
Yeah.
robotics, huge robotics, robot manipulators manipulating the frame of the car and moving it around. When I first joined Franca, in my mind, I thought that the automation in factories was a solved problem.
Hmm.
That was my perception back then. And then I asked the experts around, and they told me like even in the most automated manufacturing production line, which is probably Daimler. Can you guess how the percentage of complete automation around the production line? Can you make an estimate? It's really impressive.
Production line, it should be around like at least 60-70%, right?
Ha! That's what was my perception as well. It's 20, maybe 25. That's the best thing you can get right now with this current technology. Everything else is handmade.
That's shocking.
That's it is. So you can imagine how much potential there is for automation, and I think so many people know that. So that's like to our listeners. If someone has a huge idea and he's daring enough to automate that field, by all means, go for that. Like it's. Although, yeah, it's strange times we're living. Let's see how
Yeah.
that goes with the production lines because the production lines right now at this point are not in the yeah heaviest load ever. Let's see how that goes. But yeah, 20 when I first learned that, like I was like, why? And people told me like robots are dangerous. You don't want to be around the robotic manipulators. Like they're super stupid. They don't have perception. What they know is that they need to execute a path, a trajectory, and that's it. If you go around this trajectory, you're done because they're super huge and they have huge high velocities, and you don't want to be around. Actually, if you read around the press, like reading that a worker was killed by a robot, like that's pretty much one article per year. That's pretty much the norm. That's very unfortunate, but it's
Skynet has started.
yeah, robots kill in production lines. Robots kill, and they have huge fences, and they take so much precaution. So even if you have technology that is capable of working around people, you need to prove it. You need to have ISOs, and this is where the technology is standing now. Right now, not that many people realize robotics just started to become adaptive, to have the sensoric information to make sense of the world and make sense about the forces that are being exerted to them, and trying to be safe. And this is exactly the innovation that Franca brought to the world. It's not the first robot that does that. The so-called collaborative kind of robots that are able to sense forces and sense collision, and being able to being safe around them. And I can confirm that, like even in our testing facilities, working around the robots, I had zero cases of me being in danger. Although I usually run some crazy algorithms around sometimes, but I can confirm about the safety and being it's safe to be around. Um, this kind of robots were existing until, but they were mostly research efforts, and they were super expensive and proprietary. I think Kuka's equivalent robot was like 100,000 euros. So for all the guys that tried to do robotics, if you were not in one of the most fancy robotics labs in the world, it was really hard to test your ideas, to find robots, and usually you had to program everything from scratch, or you had to build something on your own. And this is where Franca comes in. And Franca, the vision of the company was like to democratize the access of people to this kind of robotics technology, bring robotics costs, bring top-notch technology, this kind of performance to a broader scale of people, um, to researchers, to industry, to first of all experiments, make sense of the technology, bring new technology, and I think it was in the end a huge success because nowadays all the top research papers you read, you're gonna see a Franca robots being being around, trying to assist the research and also in production, trying
I think it's
to
called
make.
Panda, right? I th-
It's called Panda,
yeah.
indeed. It's called Panda
I
robot.
saw it when I was researching. It was quite an interesting little robot.
It
But my
is.
question would be like, why aren't there like software environments that people can go test like
Yeah,
their code there? For example, in the AI world, when you want to test your reinforcement learning algorithms, which are usually agents like people that they're doing actions within an environment, and you have to set up the environment, and then you leave
yeah.
your agent in there and does whatever you programmed the agent to do. Why there isn't such a thing in robotics?
Yeah, that's a perfectly valid question. Again, it was big surprise of mine when I started writing my master thesis. Again, I thought that was another solved problem, that you have this super fancy simulator that's just gonna throw in code. Because especially for our with our background from electrical computer engineering, for example, for electronics, you have perfect software for building electronics and super complicated circuits that you don't even need the hardware. You can fully emulate the behavior of your electronics. So it was a big surprise to me to see that the available simulators around that time, and still, I would argue, are not able to capture enough of the complexity of our world when it comes to manipulation. You know, our world, we can simulate some stuff perfectly. We have the knowledge, and computationally it's not that expensive. For example, we can simulate any rigid object as a fact. But when you go to nonlinear parts of the equation, when soft materials come into play and nasty friction, especially the ability to manipulate has everything to do about the friction of terms, and these are some super nasty dynamics. I mean, of course, it's known physics, but writing the model, finding the right parameters, this whole thing is super challenging, and there is not such a standard thing as a universally accepted broad simulator that you can just test your code and then deploy it to a robot and expect it to work. This is a very promising research subject nowadays, so-called the sim to real, simulation to reality, and there has been some amazing work being performed nowadays. And the main focus of that, the main idea is, instead of trying to make the perfect simulator, that captures, as perfect as possible the real dynamics of the world, try and increase the variability of your parameters in your physical in your simulator, so your controller can be robust enough, your agent can be robust enough to capture the variability instead of capturing the world as an idealized thing. And that's amazing. Like, OpenAI has done some amazing work in that. And I don't know if you've seen the Dactyl project. They advertised
No,
it a lot, and
I haven't.
therefore highly recommended to everyone. The level of manipulation they try to achieve, a big part of it is around the central theme of not making the perfect simulator, but increase the variability across your experiments and your training. And that's big. I think that's a game changer, and I think we're gonna see in the future more pull in this direction.
And I love it that you said that, because the first image when you're saying it's hard to friction and it's hard to model the real
Yeah,
world, the first thing that came
absolutely.
to mind is like you simulate one situation, but the real manipulator is rusty, is full, it's not
Yeah,
well
yeah,
oiled, it's squeaky, and you're trying to do the
yeah.
same thing.
It's a big thing. Like, that's a very classical scientific problem. Like, it's not new. People in science, like, they try to go around this topic so much, and from complex dynamics, nonlinear dynamics, to chaos theory, to statistics, probabilistic models. In the end, everything comes up to that. That's we try to simulate to understand what's the reality behind that, like to make sense of the world. And yeah, that's a very central concept to robotics as well, of course. Interesting also, I would like to mention that it's like, it's as humans, we have some bias, let's say, and some precondition on what we perceive as hard, as difficult to be. Um, One of the hardest things to do in robotics perspective, computer science perspective as well, is just taking a glass of water and drinking it. This action of you planning, actually grasping the water, estimating its dynamics, getting it to the air, getting it to exactly position, not spilling water, and drinking and pulling back. Oh, like even if you try to put every action into a sheet of paper, you're gonna end writing a book easily. Like, but if you don't try to come to understand this problem, like you never realize that, because we are so good in doing that into our everyday life, and you don't realize that that's a fundamental flaw in the whole field. And I think that has pulled robotics back for a long period of time, because you can imagine being a venture capitalist or something and giving money to roboticists doing a simple problem, let's say. You would expect that they would solve it in a couple of years, and nope, that's not the case. But I think the industry and the market starts to realizing that. And I think maybe Boston Dynamics, taking them 20, 30 years to bring the first product into the market, that's a great milestone for the robotics community. I think that's going to drive innovation, and we're going to see more commercialization of robotics anytime soon. I'm really optimistic about that.
Yeah, it's as easy as predicting the stock market. Everybody said that
Yeah.
it can't be done. In any case, though, well,
Yeah.
forget about that.
True.
You obviously have a good grasp of the field in Europe. Do you have any line of sight of industries around the world? Is there a difference in philosophy between North America, Europe, Asia on the way they approach the automotive industry and robotics?
Again, correlation between robotics and automotive. You're focusing on the production, but because the thing, this question confuses me a bit, because nowadays cars are giant robots on wheels,
Yeah.
especially Teslas and this kind of technology. It's like you have exactly that. It's a robot. It's a robot, especially when it comes to autonomous driving. So you have robotics affecting production, and you have robotics affecting the car itself. So your question is focusing on which
So
side
along
mostly?
on the lines of, we said that Tesla has the idea and the philosophy of a supercomputer within the car, and that's
Yes.
it. Europe has, and as you said, Asia, they're preferring the controller and the distributed
Yes.
application paradigm. Are there any other differences in philosophy on how they they work in their automotive industry?
I haven't worked in the US, so
I'm just asking if you have
but
any
this
line of sight, or if
but
you heard anything.
you know, I don't want to repeat stereotypes here, but this school of thought, this line of thinking that suggests that maybe in the US there is more realm, more it's a more place for innovation and to risk, and Europe is more conservative in a way. I would say, with my experience, that there is some reality into that. So, especially southern Germany is a place, and this part of Europe, the Central Europe part, is it's well known for its conservatism, let's say, and that's not necessarily a bad thing. It's a philosophy, it's a tradition of doing stuff. So they're very reluctant in abandoning maybe some old ideas.
Something that
You
works.
can
It
imagine also.
works, right?
Exactly. And the tradition goes in so many levels and direction, especially in Munich, where I'm living. I mean, even the city itself is like a medieval city. Like in Germany, they try to keep that. And you can also imagine the emotional connection that these people have with traditional automotive. You can imagine, like, diesel was a German. Otto, that has the gasoline engine, is also German. So this is deeply rooted in the culture. So just a southern African boy going to California and building an electric car. So whatever, they won't abandon this tradition that's 120 years old for just going electric. It doesn't work like that. So in that sense, I would say that for Europe, for the good and the bad, this conservatism, it's still at play, and it's not coincidental that you don't see many unicorns arise from Europe, and especially in Germany. Like, for the size of the country, you would expect more, and I think everyone agrees here on that. Like, you would expect more for the size of the country, the leading global position, but that's not the case. There are so many factors around that. It's a very complex issue, but it's a different philosophy of thinking things. Again, I'm not saying that something is bad or something's wrong and something's better, but it's a philosophy of thinking things.
Yeah, and I think that like for German cars are very well known for their sturdy build,
Yeah,
like the
yeah,
quality of the material. When you close the door of a German car, you can understand that this thing is
great point.
is
Great points.
tested, is
They love
so
that.
much attention to detail.
I have to say that even the doors at our houses are like that. They really I'm not kidding. Like, they have amazing doors. Like, that's they pay attention to that stuff, and this is also a competitive advantage that people have here. It's attention. Like, they're super good at hardware. They're
That would be my
super.
point. Like I believe that the Western or the North American philosophy would be more going through the software, and the German and
Yeah, yeah,
European would be
yeah,
more about
absolutely.
hardware.
And you see that, like, that's an amazing example right now. That's it's becoming a huge issue. You know, the answer, like, we're waiting for a Tesla killer, an answer from the German automotive industry for 5-6 years now, and it's supposed to come this summer with the Volkswagen ID.3, and they have everything ready in terms of hardware. And actually, all the people from the automotive world testing the car, they say that's amazing, but they say they're gonna postpone the production and delay it till September because the software isn't ready. So it's exactly that. It's a manifestation of that point.
Interesting, very interesting. So let's go to Tesla then, because this boggles my mind, and I don't understand like how this is possible. Like how Tesla
No, that's very typical for Tesla. Not that many people realize that.
how from a niche company to be ahead of titans in the industry like BMW.
Yeah, yeah. That's amazing.
How this happened, and
It's
what's the disruptive force behind Tesla? Is it the electric car itself? I don't think so. Many other companies have done electric cars. What is the
no, like,
disruption force behind Tesla?
Tesla. That's I mean, no. Can you imagine, like, 2015, 16, 17? Even now, some people, they were not taking them seriously. Like, no one was expecting this kind of disruption. Like, trying to analyze deeply the roots of that. I think Elon's philosophy of, another interesting point is that 2013, BMW was at the forefront of the electric cars technology with the BMW
Yeah,
i3. So everyone was expecting that, it's done. Like, BMW is making electric cars now. It's okay. It's a solved problems. And 7 years after, they haven't responded to the Tesla Model S. Like, they haven't managed to produce a BMW 5 kind of series that will be an answer, direct answer to the US and Elon's Model S. Um, so it's a very complicated issue to see. I think, again, Elon's philosophy. Elon said, "I'm not trying to make the best electric car." He says, "I'm gonna make the best car. Period." And in order to make the best car, you need to go electric because the acceleration is amazing. So that's the key point. BMW wanted to build the electric technology and having the BMW i3, but in a way that it's not going to cannibalize the rest
hmm
of the
okay.
production. Another point that I see super relevant, and I don't think that many people focus on, is that again, in the US, people can optimize around the technical issues and optimize around the product. BMW, Audi, but that's the case with Lockheed Martin and all this Boeing and all these huge corporations. They're not optimizing around the product. They're optimizing also around politics. They optimize around job creation. It's not just a car, it's so much more. Like it's very typical. Like if you go in a party, social gathering in Munich, and you ask people what they do, like something like ridiculous, 8 out of 10 will say, I'm doing something for BMW, either directly or indirectly. BMW is like Detroit, what Detroit was around General Motors. So can you imagine the size of what's happening here? What's the stake? The stakes are like if you go electric in a day, there's so much people, so much expertise. Like, what's going to happen with them? What are we going to do? You need to transform the industry in a slower pace that is more socially acceptable as well, and it's also realistic for the society here as well. It's a very complex issue, and the thing with the US is that because they're structured differently, they have a very
Well,
different thinking
they don't have
around.
a social aspect in their
Exactly.
government, right? In their
It's
politics.
it's a different philosophy. It's a different way of thinking things, and that gives them the freedom to do that kind of stuff. But at the same time, in crisis like that, you read about 30 million unemployed people. Like, it's
Yeah,
philosophies. You see two philosophies at play, and you see how these philosophies also manifest themselves into products and all this stuff we're talking about. It's very complex to say what's the play here, the interplay.
but again, what is the disruptive force? I don't understand it. Like, if first of all, the Tesla, the SUV, the YX, what's the I don't remember the.
Yeah, it's
It's like two
SX.
hundred fifty thousand Canadian
Yeah.
dollars. I could
Yes.
get like, what's the best BMW M6 I don't know. It is gonna be half the price, and I you can't tell me that's a better
Have
the
you
Tesla is a better product.
have you driven a Tesla?
No, I haven't. I haven't.
Highly recommend. Then I think you're gonna get some answers, some really direct answers, because I
Other
highly
than the
recommend that. Like,
acceleration and
okay,
deceleration, right?
I'm not promoting Tesla. I'm just,
Yeah, dude,
but
I like them too. I really and I think that we should be conscious on the planet and
yeah,
in the
sure,
future. Um
they're super cool.
but as a product, because you said we're talking about products, and I definitely believe that cars are products, and we should treat them as such. I'm having a
Mm,
hard time.
um, highly recommend that you drive one. You can just go to it online and just write them, and they're gonna call you for a 15-20 minutes drive. It's really easy. I've done it
Okay.
because I've had the same question as you. I was not expecting much, to be honest, and I drove this Tesla Model S. Okay, I was impressed at this precise moment. I was driving the Model S, but then something more interesting happened. Then I drove a BMW. They have this car sharing concept here. I
Mhm.
think it's also a thing in
Yep.
US and Canada. So I drove a the BMW. Was a really good model. It was a Model 3, super equipped, super powerful, and it felt old. After the experience of Tesla, I was feeling like I was in, the phenomenon is exactly the same with what happened to me, and I guess a lot of people, with the iPhone. After you got the iPhone at your hand, going back to a Nokia was like, what? Okay, no, it doesn't make sense anymore. Like, wow, it feels old. It feels old century.
Wow.
You, this is exactly, it's a
It's a
very real thing,
huge
and
comparison, dude.
it
It's like
is.
it's
It
like
is.
an era, like an era.
Yeah, totally. I highly recommend you experience that, and it's really easy. Just go online, book, because the philosophy of Tesla is that another thing that um, in their they call them the Tesla, not shops, because they have like this Apple strategy of having a dedicated building
Uh huh.
for selling cars. If you go to their facilities, they don't have this smokiness and that we get from another kind of car company. They're very friendly and they're open to people try them, drive them and whatever. And so highly recommend that to anyone. So you get this iPhone moment. So for me, that was huge. and unexpected, to be honest. And I hear that from a lot of people that do that now, that's looking for a car and they cannot go back. Going to internal combustion engine after that doesn't make sense. It's big.
That's a huge comparison you make. But what do you think is that? What's the attribute? Is it that that is electric or something different?
Yeah, big factor. It's the electric, the fact that you just floor it to, and with just thinking you go to a place without this delay that the mechanical thing is having. In traditional internal combustion thing, just floor it and then you wait a bit and then something happens. That's big. And also the software at Tesla's is on a totally different level. The experience and the simplicity of it and the whole, it just works. It makes sense, and I totally dig it personally. So yeah, I hope I answered.
Oh,
your
definitely,
question.
more than answered. It's like I have to drive a Tesla then. That's
It's easy. Just anyone can just go there, and for me at least was a very nice experience and highly recommend it. But the problem then is that you won't want to buy a traditional car. It's just gonna wait for the right stuff.
for sure. So what I'm taking from our conversation is that I should go to a Tesla and drive one.
Again, I hope I get some kind of promotion.
Yeah, for sure. I'm gonna send a couple emails. But closing our conversation, can you give us like a 10-word summary of what we should definitely remember from our conversation?
Okay, that's a good point. Especially mostly for engineers that are at work and they feel that something is because in technical terms sometimes we grasp things that maybe managers and top level marketing guys sometimes they don't. Just listen to your inner thing. Just listen to your thing inside you that says something disruptive is happening outside and might be well to contribute that to contribute to that. And this inner voice, we should give more place to that. That's I think the biggest thing I hope our conversation could do that. At least it worked for me in a great way, and being able to change from industry and from domain to domain and meeting all these great people and getting a good grasp of all these different technologies. That was the big factor, just don't wait for other people to tell you, just listen to you, this voice, and let it guide you sometimes. And that would be super beneficial.
That's a great takeaway.
Yeah. Let's take then, but
no, that's a great takeaway to have from our conversation, and I generally feel the same way. You have to trust your feeling. Thank you, Konstantine, for helping me back up our bounds and all these great insights.
Thank you so much for having me. It was great.
This is it. Your mind is now backed up. To learn more about the topics discussed or the guests, follow the links in the description. Now you have the chance to subscribe, rate, like, dislike, and review the show. Also, looking forward to hearing your thoughts in the comments. Awesome. Thank you so much for joining me, and see you next time.